All right, people are filling up. We got 61. Can you guys hear me? Thumbs up. Cool. All right. This is this is gonna be insane. Zoom can only handle like 50 screens at once. So right now we have 63 people. We got a chat. That's good. Let me see what's going on there. Yeah, so people are talking about study buddies, that sort of thing. Uh, I'm gonna let you all over the next couple weeks uh, sort of form your own groups of about 4 to 6 people, and then I'll poll you all and see what groups exist, and then we'll start to assemble those groups for an eventual podcast project towards the end of the class. But I want you to have the freedom to choose your own groups rather than let some idiot AI from Palo Alto choose it via Zoom. Okay, got 80 people. What time is it? 2 p.m. exactly. Let's give it another 3 minutes since it's first day of class. I'll keep on checking out the chat to make sure that okay. Should all be muted on entry, but if you want to unmute and say anything, you're welcome to at any time. We're up to 89. I don't even know how many people are in this class. I think like 120 or something. Hey Charlie, I did send you an email about my enrollment. I had to drop this class, but if you're cool with it, I'd like to attend without getting credit. Yeah, if anybody wants to hang out, they're welcome to. Oh, that's Giancarlo. Okay. Apparently I'm not supposed to say names though. Some sort of like privacy consent thing. I'm gonna screw that up again and again. It's 202. I'm gonna be making all sorts of awkward head movements because I have like 2 screens. I have all you on a screen over here, and then I have like my lecture here.
Nice. Professor, could you explain what this Discord is?
I don't know what the Discord is. From my understanding, Discord's like a mic chat room of sorts. I've never actually participated in a Discord. I won't be on that Discord, but it sounds like it's a resource that a student is already starting. So it's, I suppose, for peer learning for you all to benefit from. But it's beyond the scope of my engagement. Group server where we can all chat. All right, there's no way I'm going to be able to follow this chat while I'm doing lectures because it's just going to be ripping like a Twitch stream or something. And so if you type something in chat and it's not recognized, please just speak up. Or if there's a particularly extroverted student that is understanding the subject matter very well and they're bored, they can be a chat janitor for me of sorts. Basically, let's all work together here. Okay.
I'm definitely down to help out with that as a very extroverted student.
Okay, thank you.
Got you.
That's great. I really appreciate that. I'm seeing a lot of people with their videos on. That's great. It helps make the class more engaging for me and for us all. But you are not by any means required to have your video on. I understand that there could be issues with bandwidth, or maybe you're not comfortable sharing your current location, all sorts of reasons, right? So video is not required, though it is encouraged. Okay. All right, I think it's like almost 2:05, so let's get going. I'm gonna try to share my screen. Where am I? Okay. Maybe I should do a quick like poll, um, just to test that out. Not a formal Zoom poll, but a little hand wavy one. So at the bottom of your Zoom panel, your Zoom controls, you can see a tab called Participants. You can go ahead and click that up. Click that, and it should open a participant pane that is going to be way too small. Pop out. Yeah, I'm going to pop this out. All right, so I can see about 100 of y'all now. And on the participant pane, you'll see a couple different responses that you can click a green check yes, a red check no, go faster. Somebody already said that. Okay, let's start speeding up. And thumbs up and coffee. I don't know what that means. Maybe you need to make tea or something. So let's just start with a yes and a no poll. How many are you are freshmen? This is your first quarter at Western. Okay, so quite a lot of you. Well, this is good. It's going to be interesting. I'm sorry about the apocalypse and that your first university experience is online, but the topics we're going to discuss in this class are very appropriate to everything that's going on in the world, and I think that we'll learn a lot of skills to help make the world a better place, and so that should be encouraging. But welcome. I encourage you freshmen in the class to team up, in groups of 4 or 6 to become a study cohort. I know that there is a freshman interest group already associated with this class. It's like a bunch of smarty pants. So find one of them, that'd be good too. And we can move on from there. All right, let's clear the votes. And now I want to know how many people are not STEM majors. How many are taking this as a GUR to fulfill like the math or science credit? Okay. Great, there's a lot of you. I love that. I'm surrounded by mathy science people my whole life, and it's nice to find balance with people that are more inclined with the humanities and the arts and philosophy and the actual important stuff in life. So this is great. Please don't be scared at the start of this class. It does get a little like mathy, like bad taste in your mouth, math stuff. Maybe some of you haven't seen math since high school. Please don't be scared. We'll walk through it. And because this is, I can't really hold office hours, I'll make a Calendly post where I'll have like a segment of time where you can sign up for office hours once a week. I'll kind of figure that out over the course of this week. But I will have a dedicated class period for homework help for each homework. So I think there's going to be about 5 homeworks, and I will spend a 50-minute section on one of these days, Monday, Wednesday, Friday at 2 p.m. to 2:50, where we just do the homework together. And so if you show up, you're going to get an A on the homework. Moreover, I'm going to post these lectures to YouTube, so you don't even have to show up. You can just watch the YouTube video later. But please come to class if you can, because it's more engaging and you can actually ask questions with all of us. So don't be scared about the math. It's going to come fast and heavy these first 2 days, but I just want to give a taste of how bad it gets, and it doesn't get any harder than what you'll see today and Friday for the whole rest of the quarter. And please use me or our illustrious TA, Josh. Josh, are you here? Let me see. Oh yeah, I see here. Josh Schreier. He's somewhere. He's the heavily bearded individual. He's up in Anchorage, Alaska right now, but he can be available too, and he may set up a similar type of office hour situation. So if you're scared to talk to me about math, talk to Josh about math. Talk to each other about math. I'm a physicist by training, and I learned all math from my peers, right? I had a group of few other people, most of them smarter than me, and we'd work together and crank through problem sets. And I taught myself and I learned from my peers. That's honestly the best way. But if you're introverted like me, then, you know, and you want a one-on-one with me or Josh, then just reach out, email, or as soon as we get some office hours set up, that'll work too. Okay, I think that's enough kind of general overview. Let me scan this chat a little bit. Not hearing much. What is with the echo? Is everybody hearing an echo? Okay, so that might be someone with their own mic picking up my voice and then recasting it through your speakers. So check that out. I do have an air purifier going on in my room, but I'll turn that off to get rid of some noise. The whole West Coast was on fire, remember? So I was trying to keep things clean in my house, but it's now that we have the rains, the air should be a lot cleaner now. All right, let's get into this a little bit. Maybe I'll start with the class norms. Normally I end with that, but I wanna let everybody know what's going on because this is a new situation now. So share screen. I will grab this PowerPoint. See if that works. And I'll blow that up. All right, minimize this other one. Well, I can't see all your brilliant faces anymore, but I'll just have to make two. Okay, oh, I found him again. Now I don't know where the chat is. Somebody just help me out as we go along. Okay. Now, do you see the
chat should pop down, like you should be able to see it at the top of the bar. It like pops down. There's a pop down menu.
Oh, at the top, yeah, thank you. And it looks like it's sharing. I still don't see the chat. I'm sorry. Now I see it again. Maybe I'll share screen a slightly different way. I'll just share the whole screen instead of just the one. Okay, and I think you're seeing the wrong slides, right? Like you're seeing my notes rather than the actual presentation. Is that correct?
We can see the slides. I
Okay.
can't see any notes.
Okay, great. Well, let's get going then. Where is my chat? I can see it here. I can click chat, but it doesn't go anywhere. Okay, here it is. All right, so this is Energy and Society. Welcome. It's a GOR course, and so I'm not here to weed out people. I'm not here to find the next greatest energy scientist, the next best thermodynamicist, the next best Richard Feynman or astrophysicist or anything like that. This is a course to get you all excited about energy, learn where it comes from, learn how you use it in your daily life, and learn how it impacts the world around you. Energy is this fantastic resource. It affords the quality of life that we all benefit from, but it's also a destructive force. It has the capacity to cause change, and not all that change is good. And so we'll get into all those topics and more as we continue on. But first, I want to get to the norms, which I think is towards the very end. So scream through all this because I don't know where my little side panel is right now. And so here's the norms, basic ideological constructs, how I would like to conduct the class. One, respect class time. I'll try to show up 5 minutes before lecture, and then I'll hang out after lecture for, as long as it takes to answer questions if people have them. Feel free to pop in and out of lecture whenever you want to, but again, I encourage you to hang out as much as possible. You'll get more from it. There's that Woody Allen quote, showing up is 50% of the battle. I honestly think it's like 80%. Any success I've ever had in life is just basically from showing up and giving a damn. Participate, but don't dominate. It's another key component here. So I love when people ask questions. I love when people speak up and ask questions. But if you're the individual that keeps on interrupting or asking questions in class, you'll start noticing nonverbal cues from your classmates. You'll notice some like sighs and some like rolling eyes. Just kind of pay attention to that. And if you start to dominate too much, try to govern yourself. And if barring that, I may speak up. Number 3 is the most important point. No silent confusion. If there's something you don't get, that means there's at least 10 more people that don't get it either. So don't suffer in isolation, right? We're Americans. Be loud. Let your grievances known. So no silent disagreements either. So this is kind of an important one. Energy is a very politically charged topic. I said this in my intro video that people say money makes the world go around, but it's truly energy, and energy is power. It's the capacity to change things. And so it has this huge component of politics associated with it. You can hear Sarah Palin say "drill baby drill" in reference to Alaska, or Trump talking about wind turbines ruining his golf course. Calls them windmills. They're not windmills. We're not making grain with them. We're making electricity. And then obviously different renewables are more left-leaning. Unless you're far left, like the Sierra Club, then you hate things like hydroelectric dams. So it's very politically charged. So I'm going to say things that are going to piss you off at some point in time. It's going to be impossible not to. So I don't want silent disagreements. We're trying to make the world a better place. We're trying to encourage debate and reach some optimal solution through informed dialogue. So let's have one. Information technology. This is more for like in-person lectures. I completely encourage information technology use. I'm a millennial myself, even though I don't really subscribe to generation theory. And so I've never not known having technology all around me. And you all are, even far younger than I am. So I'm not going to get huffy if you're on your phone, if you're using a laptop, if you're doing all sorts of things. But you're paying for this time. Use it to benefit your own learning. You're probably not going to get a lot about energy in society from Facebook or Reddit or TikTok or whatever. Okay. Number 5, celebrate, honor, and incorporate diverse perspectives. And I'm not saying this as a boiler point. I'm sure you're saying this on all your lectures, but I truly subscribe to this idea. I think the world gets to be a much better place if we all take what's good from our own personal lives and personal societies and upbringings and share them with each other. Maybe this is something that I'll get in trouble for saying, but I'll say it anyways. Even though I'm like stale and male and pale, it doesn't mean the class has to be, okay? So let's make things a little better. If there's something you want to tell me, leave an exit slip. Normally you can do this anonymously in the in-person classes. I don't see how that's going to be possible in this online form. So maybe there could be like, a courier, a voice that you could tell a friend and they could tell me, and that would mean it's still anonymous. You could even tell me yourself what you're thinking and say a friend said it and I wouldn't know the difference. But if you have some disagreement or some confusion or something that you're concerned about with the conduct of this class, either with me or another student, please let me know. Again, don't suffer silently. Any other norms anybody wants to add to the class? Is it possible to send messages directly to you in chat? Yes. Yeah, I may miss it, but I'll try to go through the chat logs after the lecture's recorded. All right. what's the saying? We're building this airplane as we fly it. So let's just get going and see what happens. Okay, so back to the beginning. Again, this is Energy 101. We live in the Pacific Northwest. We're judgy people, so let's start with some judgy stuff. I say this as a Californian. I didn't realize how opinionated people were until I moved up here. So think, poll, pair. Maybe I could do a breakout room. Let's not mess around with breakout rooms just yet. Just think amongst yourselves. You can talk and chat and think about this question. On average, who consumes more energy per day? A vegan driving a Ford F-150 Raptor gets 11 miles per gallon, or a cyclist on a paleo diet. Let's say they live in the same place and have the same commute. Picture the pre-COVID era. They both live in the same apartment downtown, and they both commute to Western, about 2 miles a day or something. So they have identical lives except for their mode of transportation and what they eat. Oh. What should we call you? Charlie's fine. Professor's fine. Doctor's fine. Even though I don't cut people, it's weird to be called doctor. What's paleo? Paleo is a step down from keto. Keto is like kind of just eating fat and meat. Paleo is you try to pretend you're a caveman, so you mainly eat meat and maybe some like nuts and stuff and kale. I don't know. Even though I think kale got invented in Italy like in the 1600s. I think cyclists probably end up being the same. I say paleo man, vegan. Yeah, paleo. Meat is crazy inefficient to produce. I feel like the Ford has to consume more than paleo. Anybody want to be brave enough to speak out loud?
I can, sir.
Yeah, sir. Yes. What are your thoughts?
I was thinking the cyclist on the paleo diet because when you're eating a paleo diet, you're consuming a lot of calories than what you would receive from vegetables. And paleo diet, it contains a little more fat, but you're eating healthier fats and if you're a cyclist, you're going to need a lot more energy. So I'd say, and you're probably going to have to consume a lot of those calories. And that's why I said the cyclist on the paleo diet.
Those are all excellent points. Yeah, raising cattle is incredibly inefficient. And
also having. So the question is, who consumes more energy per day? And I'd say, barring production of the meat, it would have to be the Ranger or the Raptor, because gas is really dense in energy.
Right. And you have to push that giant machine 2 miles up a hill.
But if we're counting production, I'd say paleo.
Yeah, so this gets into some interesting nuances, right? And there is no clear-cut answer to this, actually. It depends how far up the chain you go, the production chain. So there's a whole field of science called life cycle assessment, where you try to determine how much energy and materials goes into making anything. We'll talk about it a few lectures from now. So yes, a lot of effort and machinations go into producing cattle, beef cattle, and a lot of production and machinations and materials go into producing a Ford Raptor and the gasoline that goes into it. Anytime you see something that's not natural, a lot of energy went into producing that ultimately. Yeah, is the vegan diet homegrown or trucked up from California? Yeah, so many different nuances, right? Are you getting a CSA box, community supported agricultural box from your neighborhood, or are you getting uh, rare vegetables shipped from New Zealand or something? So these are all good thoughts, good thinking. Before we get to the answer, though, I want to go through a little bit of basics that we need for Energy 101, and that's mainly units. We need to understand what energy is, at least from a unit basis. We'll actually get into thermo in a couple of days. Okay. So next couple of days, next 4 lectures, including this one, we're just going to learn about personal energy use. We're trying to figure out how much you use as an individual before we scale it up to society. Because you are, an atom in society, and we can add us all up and think about how society uses energy as a whole. So big idea number 1 for this class is personal energy use. Humans are exosomatic. What the hell does that mean? Exo means outside. Soma means metabolism. It's not the drug in the Aldous Huxley Brave New World book, though I guess it is, but it means metabolism. So exosomatic means outside of your own metabolism. You talk to the anthropologist, and maybe there's some anthropology majors in this room, so I mean no disrespect. I'm just being a very closed-minded physicist. But when you talk to an anthropologist, what makes a human? Some will say it's language. But of course, there's several other animals that have languages. A more modern definition was humans share ideological constructs. We have culture. That way, you can travel halfway around the world, and if you hear somebody say "dude," you'd be like, "Oh, that's an American," and go start talking to them right away or something. So humans have this way of sharing cultures and ideas. And so that's maybe a uniquely human thing. But there you can also see cultures and idea sharing among different animal species. But I think the thing that's most uniquely human, again, I say this as a physicist, is that we are exosomatic. We're the only animal that I know of that uses energy outside of ourselves. Every other animal, they eat energy and they use that to grow, repair their body, and reproduce. That's it. We're insane. We use energy all around us to continue to manipulate our environment. I watched the new Jungle Book with my 2 little daughters the other day, and one of the big themes is Mowgli stealing the red flower, fire, and that's what makes us human, I think, is using energy outside of ourselves. There are 2 species that use energy outside of themselves, migrating turtles and migrating birds, but I'm not sure if they're really aware that they're harnessing wind and ocean currents or not. Okay, so in developed nations, so Western Europe, America, more and more places like China and India, how much more energy do we use outside of ourselves exosomatically than we do internally to eat? So, I weigh 180 pounds. I need 2,600 kilocalories a day. How many more times, how many X that do I need, do I use outside myself? Any guesses? Where'd my chat go?
1,000?
1,000, that's a great guess. I'm seeing 10,000, 20, 100, that's close. 3, maybe 500 years ago it'd be 3. 120, that's getting real close. All right, so the answer is actually 140, probably closer to 200, as one person mentioned, especially for Americans in particular, because we're not bad. We have to drive farther distances because our population density is far lower than Western Europe. So we don't take trains, and we don't just go from a small hamlet to a nearby town. We have to drive a lot farther. So yeah, 140 to 200 times as much is the answer. And so what does that mean? It means that you have 140 robots working for you constantly, keeping your house warm, washing your clothes, running all this information technology, spreading communications all over the globe for you, transporting you around, taking, you know, packages from some Amazon warehouse north of Las Vegas all the way to your house, you know, in less than a day or two. So we have all these beneficial robots doing all this work for us. So it's like, that's why I have this picture of the terracotta army. It's these virtual soldiers fighting the energy fight for us. Okay, so that's gives you some idea how much energy you actually use. It's way more than you eat, 140 times. Now, when we talk about energy, we have to use the units. Now we're starting to get a little bit of math. How am I doing on time? I guess I have a watch, 2:30. Okay. So before I was an energy scientist, I was a planetary scientist, and I worked at NASA. And there's a huge cautionary tale. Now, this happened way back in 1998. So I was a little kid. So this wasn't my fault. But they built this spacecraft called the Mars Polar Orbiter. And it was built in Pasadena, down in JPL. And they used American units. So they used pound force as a measure of acceleration of force. And so the spacecraft was programmed to take an input for a steering calculation or steering maneuver in pound force. Now, Earth's a sphere, right? It spins around, and one part of Earth isn't always looking at Mars. And so as it approached Mars, the part of Earth that was actually looking at the spacecraft was Australia. Now, Australia uses standard international units, things like meters and kilograms. And a Newton is the standard international unit for force. And so they sent a command to steer the craft using Newtons, but a Newton is about 4.5 times more strong than a pound force. And so it accelerated the spacecraft far too much, and the Mars Polar Orbiter became the Mars Polar Crasher. And I don't have a picture of it, but there's this like very cartoon-esque picture of like a smoky crater on the polar ice cap of Mars where it slammed into Mars. So we need to be very, very careful with units. And maybe some of you haven't taken chemistry or physics. What is a unit? It's just a ruler. It's a measurement, right? So surely you've cooked or something like that. So a cup, you know, you make oatmeal with a cup of water and a half cup of oats. Those are units. Cup is a unit. A pint is 2 cups. And so an equivalency, you could just say 2 cups equals a pint, and you could work through the units that way. We'll be doing this all class long. But let's get into some energy units first, some ways of measuring energy. For good primer on units, energy units, please look at the first chapter or 2 of David McKay's Sustainable Energy Without Hot Air. This is a free book. I think you guys pay far too much for education. I'm not going to require you to buy textbooks. I never have any of my classes pay for textbooks. There's a few textbooks that I cherished from being an undergrad, but most of them, I don't even know where they went. So let's save money and use free resources. So withouthotair.com is the book we'll use. If you do like the book, I love the book, and so I did buy a copy. I think it's only like $30 on Amazon. It's paperback. And I really like the chapters in the book because they're kind of like potato chips. They're super short and kind of addictive, and they're not burdensome at all. So if you want to be as good at units as I am for energy, read the first chapter or 2 of David McKay's Sustainable Energy Without Hot Air. The energy unit in that book is a kilowatt hour per day. That's a mess. We'll unpack that. My favorite energy unit is a kilowatt hour. We'll talk about that in a sec. What the hell is a kilowatt hour? Energy has many different metrics, rulers, mainly because we didn't know what energy was till about 200 years ago. This French dude, Carnot, wanted to blow up English men with cannons, and so he learned a lot about energy to do that. And the reason energy has so many different units is because we didn't know it was all the same thing. We thought there was heat, and we called those calories, and we thought there was, motion, and we called that kinetic, and we thought there was like light energy. We called that, radiation in the ether. So it has all these different units for all the different flavors, all the different qualities, types of energy. But it's all the same thing. It's all energy. It's all the capacity to change the environment around you. Some standard units that we use in 2020 is the joule. That's the standard international unit. It's a Newton meter. We'll look at that in a second. A kilowatt hour, that's an electricity energy unit. Kilowatt is actually power. Power is energy over time. It's a flow of energy, but if you multiply that by time, so kilowatt hour, it actually equals energy. Kilowatt hour, anybody know how much that costs? You and your house use about 10 kilowatt hours a day. Anybody know how much a kilowatt hour costs? Where'd my chat go? $5. No, it's dirt cheap. It's like 9 cents. It's insane how cheap a kilowatt hour is. And that's part of the problem. We're like so fat in energy that we don't even know how much we're using. And that's why we're like destroying the planet, because it's just like, doesn't cost anything. All right, so kilowatt hour is a unit of electricity. Kilocalorie is a measure of heat. And we measure our food in kilocalories by, well, the food like a Snicker bars or whatever has 200 kilocalories. We call them calories, but they really mean kilocalorie. You can light it on fire and see how much heat that Snicker bar makes. And you don't light it on fire in your body, but you, in a sense, just combine it with oxygen and produce heat. And that's what your body runs on. Maintain yourself at 98.6 degrees or something. BTU, that's a British thermal unit. That's a measure of heat. A lot of appliances have a BTU rating per hour. So if you buy like a air conditioner or a boiler, it tells you how much heat or cold you can make in a space. A quad is a really annoying unit. I think it stands, I kind of forget, it stands for a quadrillion barrels of oil. Why would you measure a quadrillion? I don't even know how many zeros that is. So it's about equal to an exajoule. So that's 10 to the 18 joules, an insanely large amount of joules. This is a societal scale energy unit. So society uses about 500 exajoules of energy a year, all 7.8 billion of us around the planet. So oil majors think of energy in terms of quadrillion barrels of oil. MB is a mega barrel. That's like a million barrels. Okay. So energy has units of work, force times distance, and we'll get into that on this next slide. Okay. So energy and work. So energy, it's such an abstract concept. Physicists still don't really know what it is. It's just something we can measure, and when nature does something, when something changes, the amount of energy before is the same as the amount of energy after, it's just in a different form. We'll talk about thermodynamics later. So just, I like to think of it, if anytime you see something change in the world, like the wind's blowing outside my window right now, there's pressure waves coming out of my face, that's my voice. Anytime something changes, that's energy. This capacity to change the world around you, that's work. And so the formal definition for work is force times distance. So a push moving something some distance. And that's how a joule is defined in standard international units. 1 joule equals a Newton meter. 1 Newton times 1 meter. What's a Newton? Well, if you remember from high school physics, if you took it, force equals ma. That's second law of motion. And so a Newton is a force, that equals mass times acceleration. And a meter is a distance. So this is qualitatively what we're talking about. We're talking about some hunk of stuff being accelerated over some distance. And if we want to think about what 1 joule equals, well, then these 3 things multiplied by each other better equal 1. And so the example everybody likes to use is lifting an apple 1 meter onto a desk. So the apple weighs 100 grams, a kilogram. You know, remember your drug units. A kilo is 1,000. And so a kilogram is 1,000 grams, kilograms 1,000. And so this apple 100 grams is 0.1, a tenth of 1,000. There's 10 hundreds to go into 1,000. So 0.1 kilograms. multiplied by acceleration. Well, we're on Earth, so the acceleration is 9.81 meters per second squared. It's about 10. That's really close to 10, right? And then the desk is 1 meter high, so that's the distance it moves. So 0.1 times 10 is 1 times 1. 1 times 1 is 1. So moving this apple up onto this desk is one joule. Not too impressive, but that's what it is. All right, so now we have kind of an idea of what a joule is. The actual technical units, SI units for energy, are kilograms meter squared per second squared. If you go into energy, you'll have to study that up. For this class, leave it be. You don't need to know that. Just know that a joule is about lifting an apple up onto a desk. Okay, the other big energy unit you need to know is power. Power and energy are not the same. Journalists and reporters and even energy scientists at conferences get this mixed up all the time. Power is the flow of energy. It's kind of like speed or velocity, or picture like a river. A power is how much water is moving by you at any given second, whereas the amount of water, that's the amount of energy. So power is a flow of energy over time, and the standard metric for unit for power is a watt. And a watt is precisely a flow of 1 joule per second. So if I lifted that apple onto the desk in 1 second, I would have exerted 1 watt of power on that apple. If it took me 2 seconds, that would have been a half watt of power, but the energy would have been the same because it'd been a half watt times 2, which equals 1 joule. These units are named after dead white dudes of various degrees of balding and beard growth. All right, so here's a little picture. Maybe it'll help, maybe it won't. So again, energy is the capacity to do change, and the more energy you have, the more change you can do. And so energy is like the fluid filling up this bucket that I made it oil colored because oil is energy. And power is how rapidly that energy is flowing. So again, power is 1 watt, and a watt equals energy in joule over time. Power equals energy over time. We can rearrange this equation in many different ways, and we will do that in a sec. Okay, I'll try not to go too over, but we need to get through some of this. Okay, so what's a kilowatt hour? Let's not do it this way. Let's do it this way. Okay, I'm gonna try to go to the, I have a little, I don't know if you guys can see this, a little tablet, electronic tablet that they gave me to try to do equations on. We'll see if it works. If that doesn't work, I'm gonna switch to a second camera and just write on the old-fashioned way. Okay. Zoom, share screen. Let's grab this Photoshop, share it. All right, can you all see this Photoshop panel?
Yep.
Cool.
Yep, I can see it.
And then my chat, I don't know where it went. There it is. Okay. So let me try this. Power equals, it's getting all squished at the top. All right, we're switching to the camera. This is pissing me off. Stop share. All right, you guys can see my video. Let me change cameras. All right, you guys can see some stuff. Zoom in a little bit. All right, that's wrong. Okay, let me make this straight for you all. Awkwardly hover over this camera. Okay.
So what is a kilowatt hour? How's that showing up? Does it need to be focused? Yes. Let me turn it on. Manual focus, so it stops shifting around. Okay. Maybe I'll get a different, a little more contrasty image. That's more contrast, right? How's that look? Can you see kilowatt hour?
Yeah, we can see that.
Is it mirrored?
It is, yeah. So it looks like normal.
Okay, good. So it's not, I'm not writing backwards. Because Zoom automatically flips your face, but maybe just for you, because you're used to looking at yourself in a mirror. All right, so kilowatt hour, what is it? Well, power equals energy over time. So therefore, we can rearrange this equation just using algebra, right? This can go down here and this can go up there. And so energy equals power times time. Okay, so let's start with the units we already have learned about. A joule equals a watt times a second. You can use whatever notation you prefer. I like to put my units in brackets so I can separate them from the numerical value. Generally in all my work, I just solve equations just in pure unit form and then put the numbers in later, because you're going to get the wrong answer if your units are wrong. So focusing on units first is pretty important. Okay, so we have a joule equals a watt second, but we have this funny kilowatt hour. So let's start to try to turn that into that. So we have, I'm going to flip these around and say a kilowatt. And now instead of second as time, we have an hour equals what? How many joules? Well, recall a joule is a watt second. So we have to get these into units of watt second so that it satisfies the joule. So kilowatt is 1,000 watts. I'll tell you about Greek prefixes in a later lecture, you know, like kilo, mega, tera, pico, femto, all that exa stuff. And then an hour, this is where we start using conversions of units. Now to convert from one unit to another, you have to put an equivalency. What's an equivalency? It's something that basically just equals 1. So an hour is equivalent to 60 minutes, right? 60 minutes per hour. So I can multiply this by 60 minutes over an hour because this is the same thing. I have not changed the equation at all. And a minute is 60 seconds. Again, I'm just multiplying this by an equivalency. And so I'm killing this hour and replacing it with 60 minutes. So 1 hour equals 60 minutes. I'm killing this minute and replacing it with 60 seconds. So instead of saying 1 hour, I'm now saying there's 60 times 60 seconds. It's the same amount of time. It's both boring. So then, now my units are watts times second, because I've gotten rid of hours, I've gotten rid of minutes, and that definitionally is a joule. So I figured out how many joules are in a kilowatt hour. So a kilowatt hour equals 1,000 watts times 60 seconds. Well, that's equal to, now I'm going to use scientific notation. 1,000 is 10 to the 3. It just means it's 3 zeros. And 6 times 6 is 36, but I have 2 more zeros, one here, so 10 to the 2 watt seconds. So this equals 3,600,000 joules, or using our Greek prefixes, this equals 3.6 megajoules. But remember, this costs 10 cents. That's a kilowatt hour. That's crazy. You can lift an apple from a desk 3.6 million times and cost you 10 cents. And so what do you actually do with a kilowatt hour? You do something like heat water for your shower, or you know, if you charge an electric car with a kilowatt hour, it allows you to go about, what is it, 0.3 kilowatt hours per mile. So it allows you to go 3 miles down the road. So it's a tremendous amount of energy for only 10 cents. And this is the unit we'll be using most frequently in class, is this kilowatt hour and joules. Let me check the chat. I can see it, 60. Whoa, that makes sense. Okay, dang, that's crazy. That's what I understand. All right. We'll hit this over and over and over again. On Friday, we're gonna heat up some water and see how many kilowatt hours it takes, that sort of thing. But for now, let's get back to the, it's already 2:50. What's the answer with the paleo versus the vegan? So let me change the screen. Screen 1, share. Okay, put this up. Lost the chat, but I'm running out of time, so I'm just going to go with this. You can look at this lecture at your leisure, but in general, American drives about 10,000 miles a year, so that's 44 kilometers a day. That's a bunch of unit conversions to get there. Average fuel economy is about 17 miles per gallon, or 7 kilometers per liter. So driving a typical car is about 63 kilowatt hours per day once you crank through all the unit conversions. Then the diet side of things, well, you need 2,600 kilocalories to stay alive. Converting kilocalories to joules and then to kilowatt hours, that's about 3 kilowatt hours per day. If you were going down the paleo route, well, we'll go into this in great detail in 2 lectures from now. But if you eat dairy, that's another 1.5 kilowatt hours per day, because you got to keep a dairy cow alive. If you eat eggs, you got to keep chickens alive. That's 1 kilowatt hour per day. If you eat meat, you have to keep pigs and chickens and cows alive. If it's pure cow, they're not very energetically efficient, so it's 16 kilowatt hours per day. You still have to fertilize everything, 2 kilowatt hours per day, and fertilizer is basically made out of natural gas. We'll talk about that later. And so total for a typical American is about 12 kilowatt hours per day. For a vegetarian, it goes down to 5 kilowatt hours per day. And for someone that just eats beef, that is 20 kilowatt hours per day. And so what's the answer? Strictly speaking, that Ford Raptor at 11 mpg just burns a lot of gasoline. So it's far more intensive. But if we actually did like a full life cycle assessment of the food and the farming practices, then that would easily double the paleo dieter. And then furthermore, someone mentioned already very insightfully that the paleo dieter is going to be burning a lot more calories, right? Remember that, I don't know, you guys are probably too young for this, but there's this Olympic swimmer, Michael Phelps, ate like 9,000 calories a day just because he was swimming several hours a day. And so if we say this cyclist has double the calories, then that brings it up to 60. So it's basically a push depending on how you measure it. In general, vegan diets can be much better for the environment, and cycling is going to be much better for the environment. So if we combine those two, that'd be the ideal. I kind of perversely mix them up. Usually they don't fall along crossed ideological lines like I had it to. but I did that just to be interesting. What else? Oh, I need to switch my camera back before the end of this class. This is so much more cumbersome than a live lecture, all these different things. Okay, real quick, I'll end with a joke. Well, I should say some logistic things. Schedule, syllabus, all the homework, everything you need is on Canvas. You can take this class from Siberia, just use Canvas. But please participate, it'll make things better for all of us. But the joke, the reason this question was motivated was, well, I was a postdoc down in California at Stanford. I lived in San Francisco and I'd always commute via this Caltrain, this like 40-minute ride from the city down to Palo Alto. And the last car was the bike car. And I'd ride my bike across the city, get in the bike car. It smelled terrible. And there's a bunch of, tech boys going to Google and Facebook and everything down there. And they'd all be in this car and we'd get into interesting conversations, at least for nerds like us. And one question was posed, what's better for the environment? Someone that it was exactly this question. What's better for the environment? And we were trying to, discuss it. And then I pessimistically shut the conversation down by saying that, well, the cyclist is going to be much better for the environment because they'll be run over by the raptor and no longer contributing to environmental harm. Ta-da. Haha, super funny. Okay, that's it. See you Friday. I'm going to hang out for the next 5 minutes. If people have questions, I'm going to look at the chat to see what's going on.
Thank you. Bye.
Bye.
Appreciate it.
Yeah, of course. I'm glad you all are here. Reading isn't mandatory, but it sure helps, and it's not hard. It's free too.
Bye.
Bye.
Should we be taking notes on the reading?
Good question. It'll help your learning for sure. But this is all about how you learn best, right?
Okay.
I'm someone that learns by taking notes. I scribble all over the papers and books that I read. But some people don't like hurting books with pencils and stuff. So whatever you want to do.
Thank you so much, sir. Goodbye.
Goodbye.
Yeah, I just wanted to trying to get the hang of the college, like what's the trade-off, either getting through the reading and like the healthy balance between just trying to skim and versus actually deep read. And so,
right.
Yeah.
These chapters are so short. I recommend just skimming them. If you're having trouble with the math, just kind of work through the math on the book itself, and maybe start with looking at the homework and see what I think you should learn, and then that would be a good approach. I'm not the best person to ask how to learn because I was very hot and cold. If I was into a subject, I would dive into it and read everything I could about it and take meticulous notes and get a 4.0. And if I wasn't into the subject, I just didn't show up to class and I'd get like a 1.2. So don't follow my example. But I found that I learned things most effectively when I'm passionate and engaged and make an effort to soak it up. So if you're interested in this material, then yes, read the chapters, take notes. If you're interested in just trying to get a decent grade, then look at the homework first and try to reverse engineer what you need to know.
Cool. All right,
Where on
thanks.
Canvas can we find the homework for tonight?
Say again?
Where on Canvas can we find the homework for?
It should be in that first unit. I can pull up that Canvas page. So here, let's see here. And then I need to share my screen again. Share screen one. All right. You all see that Canvas page? And I'll put it in student view so I see what you see. Okay, so logistics, here's how you get to Zoom, schedule. I'm gonna try to post every video to YouTube so you can see it there. Here's the book, here's the other book we'll be using. syllabus. If you're a nerd, you can learn how to use LaTeX, not required. Consent form for online class recordings. This is just so I don't get sued. And then here's the homework. So I'm going to organize the class in these modules. So again, like these first 4 lectures are all personal energy use. And we're going to learn how much energy we use with these 4 lectures. So introduction, which we did today. Friday, we'll do heating and lighting. Next Monday, gadgets and food, and then personal energy, all the stuff around you, like tables and lights and stuff. And then at the bottom of each module will be the homework. And so this first one will be personal energy use. You can click it, and there'll be a PDF of the assignment, and it'll be kind of a mathy type assignment, and you work through it, and then you type it up because we're professionals. We don't handwrite things anymore. And then you submit it as a PDF. And you'll notice that it's only worth 3 points. Basically, I grade things on effort, again, because it's a 101 class. If you attempted every problem and you did a pretty good job, then you're going to get 3 points. If it looks like you were pretty lazy, only did like half of it, 2 points. If you just wrote your name or something, that's 1 point. If you don't turn it in, that's 0 points. And then after the homework's due, I'll post the key, so then you can check back and see how you did on your own terms. And then if you want, further comment or advice, then come talk to me. And again, we'll be going through the homeworks together in class. So that's where you'll find the homeworks each time.
Question about that. When are you going to go over it in class, the homework? Is it going to be next week, or is it usually?
Yeah, good question. Let's check the schedule. Again, it's subject to change. I'll try to zoom in on this. So I organized this with date, and then day of the week, and then topic, and then readings associated with each day. I'll talk about this on Friday too for everybody that missed this. And then here is when a homework assignment is assigned. So today, homework out is personal energy use, and then homework in is when you have to turn it in. So you'll turn it in Monday, October 5th. So a little less than 2 weeks from now. And then I'll always do this recorded study session, live recorded study session before the homework's due. So this one, we will work on it together Friday. I'll post it to YouTube in case you missed that class, so you can look at it over the weekend. And then the homework will be due 1:59 p.m. just before class on Monday.
Okay, thank you.
Same with, and then the next homework will come out, thermodynamics. We'll have another study session Monday in this case, and it'll be due Wednesday. So I'm making this class because of the nature of the online coronavirus and all that. I just want you all to learn a few key things, and I'm not about making things hard, right? If you show up and participate, you should get an A. And I think that's the most important thing for this quarter, is just encourage, good academic health, mental health, physical health, and get through this garbage.
Can you please talk a little about what we can expect on your quizzes?
Where do I have some quizzes? Oh yeah. So this Asimov quiz, I'll have you read a very short story by Isaac Asimov about the second law of thermodynamics, and then it'll be a 3-question quiz that will be ridiculously easy if you read the story. I just want everyone in the world should know what the second law of thermodynamics is, because it's the truest thing there is. I mean, people say death and taxes is the most true thing. Death and taxes are just aspects of the second law of thermodynamics. It's just everything falls apart and requires maintenance. So that's one thing. Let's see what else. Midterm true or false quiz. That will mainly be focused on the first and second law of thermodynamics, and I think a little bit of the Kaya identity, which is a way to measure societal energy use. And the midterm will be, I'm thinking it'll be take home, and I'll just have this one portion of it, about 15%, be this timed true false quiz that you have to take on Canvas. And that's just to hopefully separate the cheaters from everybody else. And that way, if you're a cheater, the best you'll get is like 85%. And if you're an honest person, then the best you can get is like 100%. I don't know what else to say about cheaters except they suck, and there's no way for me to really catch them or anything. And I honestly like don't have the time to worry about it, but you know, you're a bad person if you're a cheater. That's where it is. Yeah. So the quizzes won't be that serious. It's just kind of check-ins. Yes.
Could you talk a little bit more about you being a physicist? You know, I'm thinking about majoring into it, and it's pretty cool how you talked about it and stuff.
Yeah, it's abstract. Like you can't really like get a job as a physicist. But,
Yeah.
What physics is it trains you how to solve problems in a systematic way. And so you break things down, it's, you know, deduction and reduction into its constituent parts, try to find a pattern in some law of nature that explains that pattern, and then you can solve a problem. And so people that hire physicists are, you know, software companies, engineering firms, and investment firms, honestly, because you can find patterns in how money moves too. So it's really just a formal way to learn how to solve problems. And the downside of it is it can be too reductionary. So, you know,
Oh yeah.
the joke is like, you know, everything is how does a physicist draw a cow? They just draw a sphere, right?
Yeah.
Why bother with like little legs? That's just a teeny bit of mass. It's just a bubble.
Mm-hmm.
So it can be myopic, and there's a lot of like, I don't know, there's a lot of toxic masculinity in the field of physics, and so
Yeah.
that's something that needs to be corrected, and it's changing, thankfully. But yeah, I went into physics because I was interested in the planets, and to study the stars and planets, you need to know physics.
Yeah.
And then when I got my PhD in planetary science, I learned how messed up this planet was, and decided to switch fields into energy science to try to fix things here.
Yeah.
I also realized like I probably won't get to go to Mars or anything in my life, so I'll fix my favorite planet, which is this planet, because it has my favorite people on it.
Yeah.
I have a question about the homework.
Yeah.
Are like all the chapters available right now for us to read, so we could like potentially get it done early if we wanted to?
Oh yeah, everything. Yeah, you could. Well, I haven't posted the later homeworks, but as I flesh out the class, yeah, you can get everything done ahead of time.
Awesome.
Yeah, I'll start continuing to flesh out the Canvas page as I go on.
All right, thank you.
I just want to get a sense on how this online thing is going to work and how people are doing. Anything else? You guys are just hanging out, benefiting from the other questions. It's good. And again, people that need extra help with math, we can do that, you know, in this time after class. Does anybody have, now that I just have a few of you, do any of you prefer Tuesdays or Thursdays to Monday, Wednesday, Friday for office hours? I'm thinking about using Calendly. It's one of those like kind of douchey apps, but it allows you to say like, okay, here's a block of 3 hours I can hang out, and then someone can, you know, select a time and I'll be sure to show up. And I find it much better than me just sitting by myself on Zoom for 3 hours, just trying to see if someone pops in or not. And that way it's more organized, and I can, you know, live my life away from the computer for a little bit of time. Unless someone needs me, then I'll show up. Oh, I'm seeing some stuff in the chat. Why is this chat so hard to find? Still can't find the chat. I click it, it says chat, it says Alt-H. I can press Alt-H, nothing happens. If I click over here, does it show up? Just stop sharing screen, and then I can find it. Yep. Okay. Oh, 2 wind turbines were talking and one asked the other, hey, what music are you into? The other wind turbine replied, I'm a big metal fan. That's pretty good. I'll remember that. That's good. Do you teach the FIG discussion? No, Stephanie Sicilian will teach that. She's amazing. She's great. I just like listening fun. I think Erin is the one leading the seminar. Oh, maybe she is too. I didn't know. She's great too. Yeah, the Institute for Energy Studies is amazing here at Western. There's only a few universities around the world that have a dedicated like school in energy, so it's pretty great. Yeah, we're in good company. It's like UC Colorado Boulder, Massachusetts, MIT, Massachusetts Institute of Technology, Stanford, and Berkeley, and then good old us, Western. All these super fancy places. We're fancy too. All right, it's looking pretty ghosty. I'm gonna count to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. See you guys later.
Bye.
Bye.